Hi everyone, this is Zakir and this is the fifth video in our module functions. Check the previous video if you missed it in the description below. In this video, we will be discussing how to find the domain of any function algebraically without using any graphs. There are a certain set of rules one has to follow when finding the domain of a function. When we are determining the domain of a function, we search for any restrictions of the function. If there are no restrictions, then the domain is a set of all real numbers. First, let's take a polynomial function such as fx equals 2x plus 3 and fx equals 5x squared plus 3x plus 2. The domain of any polynomial is a real number. What is a polynomial? We will be discussing this in detail later in our future videos. So the domain of a polynomial is x is an element of all real numbers. If you are given a fraction as a function, then the restriction is that the denominator must not be equal to 0. Because if it is equal to 0, then the function would have no meaning, since you can't divide any number by 0. Let's take this example, fx equals 5 divided by x squared minus x minus 2. So that can be also written as 5 divided by x minus 2 into x minus 1. So x minus 2 into x minus 1 cannot be equal to 0. So this means that x minus 2 can't be equal to 0, or x plus 1 also can't be equal to 0. So x can't be equal to 2 and x can't be equal to minus 1. So these are the restrictions of this function. So the domain of this function will be x is an element of all real numbers except 2 and minus 1. So this is how it is written. Next, let's see if you are given a square root as a function. Here, the restriction is that the expression under the square root must not be negative, because then it will be an imaginary number and not a real number. So in this example, x minus 2 must be greater than or equal to 0. So then x must be greater than or equal to 2. This can be represented in a number line as shown here. The circle is colored to indicate that 2 is also included, since x can also be equal to 2. So the domain would be x is an element of all real numbers from 2 to positive infinity. A square bracket is used to indicate that 2 is also included. If it was x is only greater than 2, then I would have used the usual parenthesis and not a square bracket. Now we move to the final type, the logarithmic function. In a logarithmic function of the form fx equals log of b to the base a and b must be greater than 0. Also, a cannot be equal to 1. Let's take this example. Fx equals log of x plus 4 to the base 8 minus x. Here, x plus 4 must be greater than 0. So, x must be greater than minus 4. Also, 8 minus x must be greater than 0. So, 8 is greater than x, which means x is less than 8. So, 8 minus x also can't be equal to 1, which means that x can't be equal to 7. So all three restrictions have been found, and this can be shown on a number line as follows. X is greater than minus 4 but less than 8 and cannot be equal to 7. So we shade all this except minus 4, 7 and 8. This should be x. So that is how you find the domain of all the functions. Please see the link in the description below for the exercises on the above topic. Attempt the questions and check your answers before moving on to our next video. Now for the tip of the day. The domain can be expressed in many ways. For example, the domain of this function can be shown using a number line as shown here. It can also be shown using the interval notation, where x is an element of all real numbers such that it is from -4 to 7 union, which means it's together with 7 to 8. It can also be shown using the set builder notation, where x is an element of all real numbers where x is less than 7 and greater than -4, and x is also less than 8 and greater than 7. So those are the ways to represent the domain. With that, we wrap up this video. Please subscribe to our channel, like our Facebook page, and share this video to your friends or to anyone who will benefit from this video. If you have any questions or any topic that you find difficult to understand, please ask us in the comments below. We are always ready to help you. Until then, take care.